This video is on arithmetic sequences. An example of an arithmetic sequence is 7, 10, 13, 16. An arithmetic sequence is when you are adding or subtracting the same amount every time. An arithmetic sequence goes very well with linear equations because it is what a linear equation is. An arithmetic sequence has a recursive and an explicit form. The recursive form is very similar to our now next that we've seen before, and the explicit is just like the linear equation in y or slope-intercept form that we've seen before. So some things you need to know for arithmetic sequences is you need to know what a sub 1 is. This is your first term. So a sub 1 means your first term. A sub n means the nth term. This means any term I want to know. I can plug this number in for n and say a sub 12, and that means the 12th term. A sub 144 means the 144th term. A sub n minus 1, got to be careful on how you say this, that n minus 1 is all in the subscript, so it's a sub n minus 1 means the previous term. So if I'm at a sub 5, then this would become a sub 5 minus 1. 5 minus 1 is 4. That would be the previous term. One other piece that you need to know is the letter D. D in arithmetic sequences stands for the common difference. This means what is common, how are all of the numbers changing? Difference means how are they going to add or subtract. So in this case, all of the values look to be adding or going up by 3. So the recursive form is written in this way. A sub n equals a sub n minus 1 plus d, semicolon, a sub 1 equals a number. You must know the previous term, the one right before it, to be able to write your recursive rule or to use your recursive rule. Again, this is very similar to going to your now next. Your now next rule is very similar to our recursive arithmetic sequence. So if we want to write our recursive rule, to do this, you need to know your common difference and your a sub 1. Because the rest of this is just like your y and your x, or your next and your now. Very similar to that. Because we want the next term knowing what we had originally. That's why we can say that this is the same as the now next. So in this case, we can see that 7 added to 3 will give you 10. 10 plus 3 is 13. 13 plus 3 is 16. We can see that our common difference will be adding 3. Our very first term that we're given is given to us. A sub 1, our very first term in this problem, is equal to 7, because we were told that. There was no ellipsis in the beginning. The ellipses in the end at the back of this means that these numbers will keep going. There were no ellipses in the beginning, meaning that 7 is your very first term. Our common difference is adding 3 each time. So every time we're going to add 3. So to write our recursive rule, we actually still write a sub n because that's what we would be wanting to find every time. That would be our next. Equals a sub n minus 1, so that's our now. And then how would we find the next term? We would just continue to add 3. So we're going to put our common difference here. Semicolon. Then we would put our starting at. What did we actually start at? So that would be a sub 1 equals to 7. This is the entire recursive rule. This looks very similar to, again, that now next. This would have been written as next equals now plus 3 starting at 7. This is the same information that we would have started at. So the next one says, given the rule, find the first 5 terms. So if we're given the rule, all we have to figure out is what is the first term, and then how do we continue from there. So our first term in this case was told to us as 14. So we know that our first term is 14. That's our first number, comma. The common difference is saying that to get the next one, all we need to do is add 8. So 14 plus 8 is 22. To get the next term, we need to add 8 again. That gives us to 30. We want to add 8 again, we get to 38. And our last one that we want to find, the 5, because we only want 5 terms, the next one we just add 8 to, and we get 46. To show what this a sub n minus 1 represents, I know that a sub 1 equals to 14. A sub 2 is equal to a sub 2 minus 1 plus 8. So I'm going to rewrite this as a sub 2 equals a sub 2 minus 1 is 1 plus 8. That means, because I know what a sub 1 is, a sub 2 will equal to 14 plus 8. And that's how we get the 22. That is what the n sub 1 is actually talking about, because it's that next number minus the previous term number, so that we can actually get the previous term. And then we can add our common difference. I could do the same thing if I wanted to do a sub 3. Now I would not be able to do this if I wanted a sub 7 right away, because I don't know what the 6th term is, and I wouldn't know what the 5th term or the 4th. I would have to actually make sure I counted to get up to it. So the recursive, you must know the previous term.